So again, if you guys don't have any questions, I'm going to ask some questions for you, but I would rather you ask some questions. Does anyone have questions from homework they've done? General questions, specific questions?
I have a homework question.
Yes.
Chapter 2, the review, number 68.
All right, let's take a look here. Yep. You know what page that's on? You might not, because you might be accessing it. Let's see.
I think it's 157.
All right, let's see. All right, 127. All right, this might be differently numbered. Yeah, that's the thing. That's why I didn't put any page numbers on the homework sheet, because if you view it online, if you download the PDF, if you get the hardcover book, the page numbers are all different. It's exciting. So which number you said?
68.
68. Is it this one about absolute value function?
Yes.
Okay. All right. Well, that's a good place to start, I guess. Okay, so let's see. I'm going to stop sharing this. I'm going to talk about what the absolute value function looks like. Does anyone remember if I was to graph the absolute value function, what it would look like? All right, guys. I know you're out there. I can see a few of you. If I was to graph x squared, what would it look like? Can somebody describe to me very plainly what it would look like?
1 and 0.
Say again. Sorry.
Greater than 0.
Okay, good. It's at least 0. Sure. What would the graph look like?
A parabola.
Sure, a parabola, which is the letter U, basically. Right?
U.
It looks like a U. I'm like, sure. Okay. Maybe not that flat on the bottom. All right. See, that's what I mean. What would a square root look like? Does anyone know? Maybe we can draw it in the air if I can see you. No? Does it? Yes, Khalid? No?
Isn't it like V?
No. All right, so you're getting ahead of me. That's an absolute value, looks like a V. A square root looks like a parabola that fell out. And it actually looks like, so it looks like a parabola had a rough night and it fell over and then its bottom half fell off. Right, so a lot of shit happened to this thing. So square root looks like this. So it's like missing its other piece. Is this sounding familiar to anybody? You're going to need to know the basic look of these graphs. Okay, thank you. All right, I like it. So I'm working my way up. What about x cubed? How would that look? Let me see if you can describe it. Oh, I like it. Somebody's drawing it for me. All right. One of my colleagues says it looks like a giraffe. He calls it a giraffe graph. And I like to give him shit because then I'm like, well, that's horrible. His front leg fell off. He's about to fall over. That's horrific. I like to give him some shit. But that works. What the hell? Giraffe graph. It looks like a parabola where one half of it just twisted around. And so why does that make sense? Why does it make sense the x squared has to turn? Because like somebody just said, the output has to be greater than 0 for real numbers, right? And normally when we're graphing like this, we're talking about real numbers only. And x cubed, of course, can be negative. Does that, you guys follow? So this is basically what x to the even looks like. And this is basically what x to the odd looks like. Okay, I like it. How you guys doing? Bowen is sending me anime cat eyes. Is that what that is? I don't know what that is. Okay. All right, now, absolute value of x. Somebody has told me what that looks like. It looks like a line that wants to do this, but it can't because absolute value can't go negative. So it's sort of like the connection between these guys. X, even powers force it positive, so it turns this up. Absolute value forces it to be positive, so it takes this and reflects it up. I like it. Now, this is good. This is going to lead into a lot of stuff here. What would this look like? What do you think? What do you guys think? Sorry, go ahead.
Isn't
Isn't it
it
like
moved
V?
over? Oh,
V to the left side, so like it's
Shift
All
it
right, it's
right
gonna,
through
yes, it's going to shift. I love it. It's going to shift
to the
because I really
right.
want you guys to understand this. The shortcut for these kind of things, where it's almost like something I know, it's just has an extra little bit in there. All of the inputs. What makes this 0? If I plug a 1 in. If I put a 1 in for x, makes this 0.
2.
The 2, yes, but this one is 0, right? This one is 0 when I plug a 2 in. You guys with me? So all the inputs have to be 2 bigger. So this is just going to be the same shape, just shifted over 2. Right, and to be really honest, when you graph for me, let me kind of make some ground rules here. You've got to show me some detail. So this, let me see if you guys are cool with this. All right, stay with me. Why does it make sense that the vertex, right? Same thing we use for parabolas. Why would it make sense that it's moved over 2? Because this is 0 when x is 2. So it's negative on one side, that's the reflected side, and it's positive on the other side. Okay. That's why the turning point is here for a normal absolute value, because back here it's negative and it's not allowed to be. The absolute value reflects it. So now on either side of 2, that's going to happen for this guy. So every point gets shifted over 2. So there used to be negative 1, 1. So now this gets shifted 1, 2 over. And this is going to go up to 1 also. Maybe a big circle. Why not? All right, maybe. So this specific problem wants you to graph not just an absolute value. Let me see. So now you should be able to figure out what something like this would be, or something like this. No, Jeff. Right? You should be able to figure out what those would look like now. Do you guys understand? Where would this guy's vertex be? Where would it move?
Would move 7 to the right.
7 to the right. I really want you guys to get that. Just like this one moved 2 to the right. And why is that? I really want you. What's the first thing I do to any input I put here? What's the very first thing that happens to it? If I put a number in here, if I put a number right here, what's the very first thing I do to it? So take this, put a 4 there. Put a 4 there. What's the very first thing you're going to do to it? No. If I put a 4 there, what's the very first thing I do?
Subtract 2.
Subtract 2. So whatever I put here, the very first thing I do is take 2 away from it. So what must be true about all my inputs? They have to be 2 bigger than they used to be. I really want this to make sense. That's why it does the opposite of what it looks like. You might say that goes left 7, but no, don't they have to be 7 bigger? I got to put a positive 7 in there just to get 0. So it's going to move to positive 7 and have a V. What's that going to do? Where's this guy's V going to be?
The opposite.
Sure. What's that mean? Yeah, to the left, right? So that'd be here. And that would be here, and that would be here, and then you got your little V. Woo. All right, so we're going to focus on those later this semester. Those are called transformations. Does that sound familiar to anybody? Transformations?
Yeah.
And then you have compressions and stretches and stuff. Oh, shit. We're going to get into phase shifts. Oh, baby. Well, I like the to the left. Okay. It's a little bit dated now, right? All right. So no. Let me, I'm going to erase all this. I'm still not done talking about this problem. Here's another idea. How do I solve, is there a way to solve this equation? What do you got, Jeff? Sure. I don't want you to use any algebra to solve that equation. Is there a way to solve that equation graphically? Do you guys know? Is there a way to solve that equation graphically?
Sure. You would need to draw the 2 lines.
Good. This is an equality of 2 lines. And they could be any functions, really. I could have put a squared there, whatever. And the answer will be where what happens?
They intersect.
Where they intersect. I love it. So I graph my x minus 4. So x minus 4, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. All right. Yeah. Graph by 2x plus 1. Oh, shit. They're going to meet way the hell. What is the answer here? X equals negative 5. Oh, they're going to meet. All right. I don't know. So here, I can go up 2 over 1, or I can go down 2, back 1, down 2, back 1, down 2, back, and they're going to meet back there. So if I go far enough, I'm going to see they're going to meet at negative 5, right? If you solve that, you can see the answer is negative 5. I can always solve, well, let me be careful how I say this. I can very often solve a given situation algebraically or graphically. Right. So this is kind of like, remember systems of equations where you had to graph the 2 lines and see where they met, right? That's basically what this is, because what's this say? This line equals that line. So it's going to be where they meet. So now we can finally do the problem. We can finally look at number 68. We got everything we need. So number 68, I'm not going to do it. I'm just going to talk about it. They give you this. Become an X. Okay. So now it's a little bit different. There's an inequality here now. What are the 2 things? So you got this thing to graph. Now you know how to graph that. It's a V. You can figure out where its butt is, right? You can figure out where it shifts to. What's this side? What does this side look like if I graph it? So this is going to be a V. What's that going to look like? No, I think I know what you mean, but no. So I really want you guys to get what's happening. So if I were to, so I can look at this side and say y equals this, and I can graph it. So if I look at this side, y equals 5, what does that look like if I graph it? What does y equals 5 look like?
A line.
A line. What kind of line?
Horizontal.
Horizontal line, because it wants y to just be 5. Wow. So graph this on top of this. And then you can see, when is the graph of this bigger than or equal to the graph of this? That's exactly how you can look at this graphically. If I graph what this represents, and on top of that, I graph what the other side represents, I can see when this side, this line is smaller, or I'm going to read it this way, right? 5 has got to be less than or equal to this, or this one has to be bigger than or equal to that. Okay. Maybe. So I'm going to end up with something that it doesn't look like this exactly. It's going to look like that. So where is the absolute value bigger than the constant? It's going to be back here and up there. So it's going to be all the x's below that and all the x's there above that. I have no idea if that makes sense to you guys, maybe a little bit. So there were kind of several layers to this problem, right? You have to remember what it meant to do these things graphically. You have to remember what an absolute value looks like. And then you have to understand how the inequality works into this. The answer is not going to be one or two things. It's going to be intervals of things. So maybe let's try a problem like this. You can do it, Jeff. Sure. So if I graph this, help me out. Where's this guy going to be?
1 to the right.
Yes, that's where his butt's going to be. I like it. So that's where his butt's going to be. And then he's going to go up and over 1 in both directions. Let's do 2, 4, 6, 8. Sure. I like it. Right. So he's going to go, I don't want to say this. So if we go back 1 and go up 1, if we go back 1 and go up 1, that's going to take a while. Now here's the 8. Why did I have to make it 8? Let's change this to 2. Why not? Doesn't really matter. Just make this simpler. All right, good. So if I do, is everybody with me so far? So I know it's going to have a vertex at 1. And the slope is 1. So it's going to go up 1, back 1, up 1, back 1, up 1, over 1, up 1, over 1. So that's where it runs into the line, which is 2. So if I graph just 2, I'm going to get this guy. Now, where is the absolute value? It should be a straight line, but you guys are going to forgive me. Where is the absolute value less than 2? Between what two x value? The answer to this is going to be related to x. So between what two x values is the absolute value less than 2, less than the green line?
From -1 to 3?
Yeah, it looks like -1 to 3. Right? And it's strictly less than, so I would say parenthesis, -1 to 3. Remember, this symbol means include, this symbol means exclude. Is everybody with me on that? The way to remember that is that looks like a part of an eye, and that looks like an open circle that somebody did that to, right? You guys remember interval notation? Is that, there's a few problems where you have to use interval notation. Okay. And again, if you don't, just say you don't, and then we could do a couple problems related to that, right? All right.
Is there another one like this?
There's some problems where you have to use interval notation. There's not another problem like this, though. There's just one problem like this.
Can we do one with interval notation?
Sure. So let's say I've got, what do you got, Jeff? Yeah, let's make this come out nice. Why not? All right, so that you got a problem pretty much just like this in this section. How do I start this off? Is anybody freaking out about the fact that there's like multiple symbols? Do you guys remember doing this? Pretend like it's not there. How do I get the x by itself? What do? You know what you have to do first. What's the first thing I do to start getting the x by itself?
Subtract 2.
Subtract 2.
Subtract 2. We know that. And what do you always do? If you subtract 2 from here, you have to subtract 2 from
Both sides.
all sides. I love it. We
All
normally
sides.
only have 2 sides. Now we have 3. So we got to subtract 2 from all sides. So minus 2, minus 2, minus 2. So see, this is me being nice here. And then, of course, the last step is 2. Is everybody cool with that? I mean, does that sound familiar? What's the last step now?
Divide by 3 on all
Divide
sides.
by 3. I like it. Divide by 3. And now just take a minute. Can you graph that for me? And then interval notation. If you forgot how to do those, I'll do it here in a minute. But just try to graph it and then try to give me interval notation. And I will say this. I don't want to see any open or closed circles on those graphs. That's math 90 shit. We're past that. What symbol do I put here on the -3?
Symbol, you said? Is it an open circle?
No, we're past that. So instead of using open circle, we do not use those anymore. We're more sophisticated. All right, so instead of an open circle, if you want to put an open circle, you instead put a parenthesis. If you want to put a closed circle, right, like a shaded circle, that meant you wanted to include that thing, right? So you would instead put a bracket. It looks like part of a letter I for include. All right. Does that sound familiar to anybody? Or did you guys, hopefully you didn't always just use circles, but this is not that big of a deal. So you would want to put an open circle here, just put a parenthesis instead. And on the -1, I'm going to put a bracket. Now, why am I opening them the way I am? Because where are the answers? The x's have to be between these two things, right? So this is where this is my Dragon Ball math. Where's my any Dragon Ball fans? Kamehameha, like that, right? So the energy comes out. Here's the hands. And the energy comes out. Here's the hands. Rah! Yeah. No? Okay. That could just be for me. That's how you know they have to open in the direction you're going to shade away from them. Okay. I like it. How do I get a cool background? You have to ask Santa for it. No, you can look that up. Zoom background. Okay. And then now interval notation is very simple. Interval notation strips away all the shit I don't need to know. So I start at -3 and I go to 1. Don't include that, but do include that. I'm sorry, -1. Do you see the connection there now? So that's why we don't use open circles and stuff anymore, because now they're directly connected, the interval notation and the graph. All right. I like it. Is somebody out there meditating?
On my mama.
That was interesting.
That's what it means.
Oh, it means oh my mama?
On my mama.
On my mama.
All right. I'm not going to do anything with that. You guys have fun with that. One Piece, I never actually watched any One Piece, believe it or not. Anyway, all right. So is that okay? Did that bring back memories? What do you do if it's not three-sided? So what do you do if you have a problem like this? What you got, Jeff? Does it really matter? No, it doesn't matter. It doesn't matter. There you go, buddy. All right. So go ahead and try to do this. Go ahead and try to solve this. Black Clover. I've heard of that one. Have you watched ReZero? What was that other one? Doro Hidoro. Have you heard of Doro Hidoro? You gotta look that shit up. Yeah, Death Note. I know that. All right. There's one thing you have to be careful about with this problem. It's specifically about inequalities, right? So let's see, go on first distribute, add the 10. And what's the last thing I have to do?
Divide by a negative, but as soon as you divide, doesn't the sign flip over?
Totally. Why? Do you guys know why?
I don't remember why.
Because
Alright.
it's a negative.
Yeah. So watch it. This is the reason. You ready? Which one of these is bigger?
The 2.
The 2. Okay. If I divide both sides by a -1, that becomes -2. That becomes 1. Which one's bigger now?
The 1.
1.
Oh, shit, look what happened. So this is my favorite answer ever. Why does that sign flip? Because that's how numbers work. Because it just does. When I multiply things by a negative, they change the side of 0 they're on. Does that make sense? So therefore, whatever was bigger is now smaller and vice versa. That is why I flipped the sign. Another a really kind of long way to see why I flipped the sign is if I get to this point, let me do something really silly. I'm going to add x. I'm going to subtract 12. Can you read that for me this way? Is everybody cool with what I did? I did something really weird, right? But still, this is all correct. I didn't do anything wrong. Well, how's this? If you read it this way, what's it say?
X over -12
X. Go slower. Say it again.
over
And then -12.
Sure.
X more than.
X greater than -12, which is exactly the same as this. Do you see what I'm saying? So this is sort of a shortcut. Instead of doing all this weird shit, instead of moving the X to the other side of the inequality, I just flip the inequality symbol. It's a shortcut. That's another way to look at it. Okay. Totally trippy. These are little tiny things that as a student, these build up in your head. You're like, all right, I'm just doing shit because they tell me to do it. It's just whatever they want to say, I just do it. No, everything you do has a reason. And don't let anything just be done because that's what somebody said, right? This could be a life lesson. All right. And then if I want to graph this, I've only got to worry about -12 now. What symbol will I use on the -12? What symbol?
Brackets.
Not bracket.
Parenthesis.
Yeah. So a student said, if you see a line, you do see how that one has like a line in it? I don't know. This is don't include. That's what this means. Don't include, and this one means include. And then I would just shade up forever. So what would the interval notation look like? I go from what to what?
the negative 12 to infinity, right?
And you always put a parenthesis on infinity, because if you put a bracket on that, I'm going to request for you to bring me infinity, because you're saying you can make it to infinity. A bracket means include. And if you want to include infinity, I think that was what was in the suitcase in Pulp Fiction, but I'm not sure. All right, I keep bringing up Pulp Fiction, I'm sorry. So never put a bracket there, because that's crazy shit, right? I want you to bring me infinity. I'm not sure if I want you to do that. I'm not sure what that would mean, but if I'm curious. And it always goes smallest to biggest. Okay. Don't do this, dear God. I love it when people put that there, and I'm like, what's this? What's that? It's infinity plus 1. No, this doesn't make any sense. Stop it. Go away. Okay. All right, good. There's a lot of good shit there. You guys with me? Yeah, exactly. I was waiting for somebody to give me their Buzz Lightyear. Okay. There you go. Yeah. All right. It's like, Buzz, you don't know any freaking math, but you're okay. All right. Anything else specific? If not, I could just, I got a few things I want to talk about. Anything else specific from chapter 1 and 2?
I have a question for number 58, chapter 2.
58. Oh, yeah. Okay. Oh, good. All right. All right. So this is kind of neat. All right, let me build my way up there. The question you're talking about is the absolute value equation, right?
I think so.
Yeah, absolute value of 3x minus 7, that one?
Oh, yeah.
Okay. Now, so let me build my way up there. What are the solutions to this equation? There's actually no work to do. You can just figure it out. What would work?
Is it 1?
Absolute value of 1 is not 4. Try again. What do I take the absolute
Negative
value?
4.
Sorry, say again. Sorry.
Plus or
Negative
minus
4.
4.
Negative 4 or positive 4, right? Do you see how there's two solutions? So the inside can equal this, or the inside can equal negative this. You guys see that? So if I put something more disgusting in here, we'll do the exact same thing. What do I take the absolute value of to get 11? So either this can represent what, or this can represent what? What could this be to make the absolute value 11?
11
What would
and
you
minus
Go
11.
ahead. Sorry?
11 and the minus 11.
Yeah, 11 or negative 11. And then you solve.
I guess I just kind of mixed up with the, so actual value equal to negative something is not working, right?
Exactly. I like it. So those, there's no solution. I like it. And now you see, why does it make sense? There's two answers sometimes, because if I have an absolute value and a constant, couldn't it meet in two places? And then you could also have an absolute value and a constant that never meet. So that would be no solution. So that if I had a negative here, this thing goes to hell, because absolute value can't be negative. But here I'm going to get two answers. Oh, here we go. I got another. Is that cool with everybody? Or, understood? You might not want to go all the way to cool. Let me see. Chapter 1, number 30. Somebody's asking me about. Oh, yeah, perfect. All right, kick ass. So let me build my way up to that. Let's see. Where'd it go? Oh, yeah, okay. How do I, all right, let me just write this word down. Rationalize. How would I rationalize this? Do you guys remember what that means? Rationalize the denominator.
Flip the square
7.
How do you mean?
So so equal 3 counts bottom.
So what are you allowed to do? What are you allowed to do with the fraction? You're allowed to multiply top and bottom, divide top and bottom, right?
I think you add another root 7.
Yes. So why is this irrational? Because the inside's only got 1 7, and of course a square root needs 2 things inside of it to be able to do it, right? So if it doesn't have 2 things inside of it, that stays irrational. But the square root of 9 is 3 because 9's got 2 3s. So what is this dude missing then? What's he missing? Which is basically what you're saying.
Another 7.
What else? Another 7. He's just, if only he had another 7 in there, then I could kill the square root, right? So do you guys remember that this is the same thing as this? I don't know if we've talked about that. Fractional powers are the same thing as radicals. I think that came up because what a square root does is cut things in half. So this is a beautiful way to look at this. I've got half a 7. Let me give it another half a 7. And of course, you know, if you multiply the bottom of a fraction, you better frickin' multiply the top of the fraction, right? Keep things legal. I don't know what kind of jail you go to. Now, and then you get on the top, you get 3 rad 7. On the bottom, what do you get?
Just 7.
7. Kick ass, because half a 7 times half a 7 makes a whole 7. Oh, so sweet. They completed each other. So let me do 2 more problems. I got to build my way up to your question. So that's this. What would I do? How would I rationalize this? What's different? How needy is this guy? This guy was kind of needy. He needed 2 things, then he only had 1. How needy is this dude? What does he need inside him?
It needs 3 more 5s.
No, it needs how many? It needs 3 total.
Oh.
I see you yelling at me in chat. It's a cube root. Yes. It's a cube root. So how many more 5s does it need?
2.
There you go. So I don't call this rationalizing the denominator. I call it completing the root. If it's a 3rd root, it needs a total of 3 things in it. It's only got 1 5, so let me give it a cube root of 5 squared. Let me give it 2 more 5s. And you can look at it this a different way. Isn't this 1/3 of 5 and 2/3 of 5? That's going to make a whole 5. Do you guys see that? That's kind of nice. So on the bottom, I get 5. On the top, I just slam those things together. Bam. Why can't I multiply 4 by 25 and make 100? Why can't I multiply those together? Or can I? Why can't I multiply those together? What's 2 times 3? What's 2 times 3?
6.
6.
What's the square root of 2 times the square root of 3?
Square root of 6.
Yes. So what is 2 times the square root of 3? I don't freaking know. I just leave it like that. So if the root is the same, it kind of makes sense. If a whole 2 times a whole 3 is a whole 6, half of 2 times half of 3 is half of 6. So as long as the roots are the same, and 4 doesn't even have a freaking root. So there's no way I can multiply those together. Does that sound familiar? They have to have the same root. Maybe, maybe, maybe. All right, something else that's going to come up this semester. Well, oh yeah, I got to take the one last step, and then I'll talk about something else related to this. What time we got? Okay. I love this shit. All right. So I like building off of questions because every question in these review sections actually has 1 or 2 or 3 layers of stuff, as I'm sure you noticed as you were doing the problems, right? So you have to kind of understand each piece. So each of them have a huge amount of shit I can talk about. So what if I had this? Sure, I like it. If I multiply top and bottom by square, no, Jeff. There you go, buddy. All right. Make that a 5, or else it's a little too easy. All right. If I multiply top and bottom by rad 5, will that make the bottom rational? That's why we call it rationalization. Will it make the bottom rational? Oh, what was the thing you said yesterday? Oh, real quick on the side. So I don't know how helpful this will be if I write it like this. The 8th root of x to the b. The root is on the bottom, right? Like on plants, right? Where's my botanist? Don't bring up tubers and shit. Most plants, the roots are on the bottom, right? One semester I did have somebody, well, technically for tubers, shut up. The roots of most plants are on the bottom. So the bottom is the root and the top is the power. That's how I go back and forth. Does that make sense? To Austin and everybody? Oh, sure. Sarah, go ahead. Sorry. Don't mean to call you out, but if you got to go, you got to go. Is that all right, Austin?
Thank you.
You're welcome. Austin, is that all right? Austin? Yes, okay. All right. This, it's got more shit down here. So if I multiply by rad 5, do you guys see how that's not going to help me out? Because I'm going to have to distribute that to both, and I still have a radical. So does anyone remember? And I know somebody does, because people have already done this problem. What do I have to multiply by? Because there's 2 parts here I got to worry about. Oh, you're okay, Austin. I didn't mean to make you feel bad about that. Anybody remember? I know somebody does, because some of you guys have done it. Bailey? No? Yes? Carolina? No? Keep.
You multiply the whole thing on the bottom part?
I'm
Multiply
not
by-
really quite.
Sorry? All right, today's been weird. Multiply by the
Square root of 5 yes.
conjugate. I like it. Yes, Jeff, I agree. And it's related to difference of squares. I really want this to make sense. Anything I put here, it's going to FOIL. I want the middle terms to cancel because that's the only place a radical would still be there. So I want to use something that looks like a difference of squares. So let's see what we get on the bottom. Rad 5 times rad 5 is 5. Plus 3 rad 5 minus 3 rad 5. They kill each other by design. I designed them to kill each other. And then I get minus 9. And on the top, I just get 7 rad 5 plus 21. Right, so then I end up with 7 rad 5 minus 21. Minus over -4. And that's fine. You could bring the negative up, I don't care. So that, anyone remember this? I think I said the word. Did I say the word? Yeah, I did. This is called the conjugate. Right, not conjugal. Conjugate. Very different. Okay. Maybe? Does this sound familiar? You guys with me? So that's what you do when you have more than one part and you need to rationalize it. You have to multiply by the conjugate, by the same terms, different sign. Okay, maybe. Does that help you out? Who asked that question originally? Is that all right? Yes. Okay. All right, now I got to remember what it was I was about to do. You can do it. Yes, I remember now. Okay. So this is a different kind of idea, but it has to do with radicals. Does somebody remember how to simplify something like this? By hand, right? Anybody remember how to simplify this?
When you simplify, don't you
You
just
find
bring
You
two
break
roots?
it down.
Oh, let me see real quick. Somebody has a question about 30. How far can 30 be simplified? Oh, yeah, you should be able to see how nothing reduced. But I think in number 30, something should reduce out of all of them at the end. There you go. Okay. Yeah, if you break this up, so I can break this up into the square root of 25 times the square root of 2, right? I can break that up. So a part that I can do and a part that I can't do. So that's 5 rad 2. And I want to show you something that you normally don't get to see. And this is a really, really, really old idea. But how would I make this into a, what do you got, Jeff? How to make this into, you can write a number. You can do it. There you go, buddy. How do I make that into a mixed number? Just go with me for a second. 7 rad 1, what happened? I don't know what happened, okay. How do I make that into a mixed number? Anybody? Anybody?
Multiply it by 5 to get 40, and then you get 3/8 from the remainder.
Oh, I see what you, okay, I got you. So here's a different way to do it. So 8 goes into 40, and I got 3 extra. So I divide the part that I can, and then the part that I can't, I just leave. That's another way to kind of look at that. Does that make sense? It's kind of a nifty way to do it. That's exactly what happened here. I did the part that I could, and I left the part that I couldn't. So this is sort of like a mixed number. Go ahead, sorry.
Why is it negative?
It's not. That's an equal sign. I don't know what happened.
Oh,
Right,
I was looking on the right side of the board.
Over there? That's also an equal sign. It just got a little mushed. Sorry. Okay. That's all right. I'm not sure where the 7 rad 1 is from. Rad 1 would just be 1. Okay. So that's how. Sorry.
I was thinking like 7 and 7 is 49, and like the extra 1 left over, you know.
Say it one more time. Sorry.
I just did 7 and 7 factored from 50. And it's 49, you know.
Oh, dude. Okay.
I don't know.
You got to be really careful. Square roots are powers, right? They're just fractional powers. Everybody with me? Powers are based on what operation? Powers are based on what operation? So
multiplication.
Multiplication. If I said do this by hand, you would do 7 times 7 times 7 times 7, right? And you would all go, what the shit's wrong with this guy making me do this by hand? But that's the idea. It's based on multiplication. You are breaking this down using addition, which won't work. Square roots don't understand addition. They can't play well with addition because they're based on multiplication. Does that make sense? I don't blame you. It's a good idea. It's like one away from something that works. But that's using addition, and square roots don't understand addition. Roots don't understand addition. Does that make sense?
Definitely.
So you got to break this up using multiplication. That's what radicals understand. This division is actually based on addition. I don't know if you guys understand what I mean. So like, watch this. Stay with me. If I do 20 divided by 2, that's actually how many 2s do I have to add to make 20? 10. So division is actually based on addition. That's why breaking this up with addition worked, because then it can actually go to both. This is based on multiplication. I must use multiplication to break it up then, right? And I have a tendency to go a little deeper than people might want me to, but these are the kind of connections that nobody ever made for me. I had to get these connections myself. But once you see those connections, it makes a little more sense, I hope. Okay, maybe. All right. It's sort of like that problem when people are, if I said subtract these, and somebody would say, well, +1. I mean, that we kind of chuckle, isn't that? You can't do that shit, right? Because we know it requires a multiplication or a division for it to maintain the ratio. We know that. Same thing with radicals. Same kind of idea. I can't break things up with addition. I've got to break them up with multiplication. Okay. All right. Let me see. Did I miss any questions? I don't think so. Okay. So there's a couple things I want to talk about from chapter 1. Oh, Julia, do you have something?
Yeah, if we could we do number 28 in chapter 1 review?
Let me see, where am I? Okay, here we go. 28. Oh yeah. I'll do one sort of like that. So let's do one level. What would this be? Write something down. There you go, buddy. Now something else. There it is. What would that be? It's as simple as your gut wants it to be. Trust me.
2/7?
Yes, it's 2/7. Square root of 4 is 2. Square root of 49 is 7. So what if I had this?
You would just use them separately and do the top as 2 different parts, right?
I love it. So square root of 20 over square root of 49. So the bottom is 7, and the top you do just like we just did. How would you break 20 up?
4 times 5. Or
Yes.
square root of 4 times the square root of 5.
Yeah, let me put it in that same order. Square root of 4, square root of 5. So then you get 2 times rad 5 over 7. So that problem you just asked about will work the exact same way, right? One of them you can do directly. The other one you have to do by parts. I like it. By the way, hopefully everything we're talking about is coming back to you. If anybody ever feels like you've never done something we're doing, I kind of want to talk to you, right? And it might be just because it's a long time ago for some of us, right? But hopefully these are things you have talked about. It's just like you forgot about them, maybe. Okay. Anything else? Any other specific questions before I do a couple? Okay, you definitely remember doing these. Yeah, it's just that they leak out your brain after a while. Okay. So what I want to talk about real quick, I back in chapter 1, a couple of the main things, there were problems like this. I think we did an example like this, didn't we? You could do it, Jeff. Yeah, that'll work. Holy shit. Right, didn't we do an example like this the other day? I can't remember now. I think so. Somebody remember how to do this?
Square both sides.
Yes, square both sides. The biggest mistake I see, one big mistake I see is for some reason people square this. No, the square died. It's gone. And then for some reason I get people doing this weird shit. We know better than that, right? What do you get? You lost the whole middle term, didn't you? So is that cool? Be really careful. Don't assume too much. All right. And now what the hell do I do?
You simplify by moving it all to one side.
Beautiful. If that wasn't there, I would get my x's on one side, my numbers on the other, right? Anytime you have a power higher than 1 on a variable, you want to get it equal to 0 because I have to use factoring to help myself, right? We have to use that other method. So let me move these over. Become a 3. And some of you guys go to quadratic formula a little too quickly. Why do you want to do all that freaking work? That's easy, right? How do you factor that?
X minus 4, X plus 1.
Yes. And then I want to also be really clear about what exactly happens. If 0 equals something times something else, then either this one is 0 or that one is 0. Now, of course, you get the shortcut of opposite sign, right? But now you see why, because you're just solving those little equations, right? Maybe. All right. Okay. Let's see, real quick. I'm not going to do this problem, but what would you have to do first on this problem here?
Divide by 2 on both sides.
No.
Subtract 2.
Say again.
Subtract the.
2.
Yes. I get way too many people that want to square. That's illegal. What just happened, right? That's illegal. You have to do the same thing to both sides, and then you would have to FOIL this shit. No. Let me isolate the radical, and then I could do everything we just did, right? Then it becomes the same problem, right? I would square this and square that, but I'm not going to do it. We already did that kind of problem. So you have to first isolate the radical. That's why this was easy, because the radical was already isolated. Once we get it by itself, we can kill it. Like it. Don't feel bad about killing it. He did bad shit. He did bad things. All right. I don't. You kill anybody? Yes, but they were all bad. Okay. I'm going to erase this. Here we go. So here's the last thing I think I want to talk about today is rational equations. What do you got, Jeff? Sure, why not? I like it. Sure. All right, sure. Can somebody tell me? Well, first off, I'm sorry, I got a question. I'll come back to that in a minute, Kyle. What's the very first thing I want to do in this problem?
You want to factor the denominator?
I like it. And I pretty much know how this is going to factor, right? How is that going to factor?
X minus 8 and X plus 3.
Yeah, be careful. Don't always assume that's going to work, but I pretty much, there's going to be hints in these problems, right? What do I do next? What's
Multiply by the ACD.
You could. Let me show you a little bit different way to do it.
You get all sides to have the same denominator.
Yeah. So what's this guy missing?
X
The
minus 3.
X plus 3.
X plus 3. So I'm going to give him an X plus 3 in the top and the bottom to make it all legal. What's this guy missing?
X minus 8.
Minus 8.
And then if I multiply by the LCD, it just basically cancels everywhere. Die, right? Why am I allowed to do that? Why am I allowed to kill fractions in this problem? Why can I kill them?
Because they all have the same denominator.
More than that. These have the same denominator. Can I kill them?
They're in the numerator and denominator, so you can cancel them out.
No, they're only in the numerator because I multiplied by it. Why am I allowed to do that? I'm guessing that's what you mean, right? I'm going to multiply both sides. I just gave it away. I'm going to multiply both sides. It's an equation. So I'm allowed to multiply both sides of an equation by anything except 0, right? Is everybody cool with what I just said? You can multiply both sides of an equation by anything except 0. If you multiply by 0, then what the hell good is that? So tell me this real quick. I just multiplied by X minus 8 and X plus 3. What would make that 0?
8.
8.
What would make that 0?
Negative 3.
Negative 3. So if I get one of those answers, I have to throw it out because then I would have done something illegal. So if one of your answers makes anything undefined, obviously you have to throw that bad boy out, right? So now I can keep going. Now what's left alive? All the tops, 4x plus 3x plus 9 equals 2x minus 16. And you got 7, you got 5, and you got, oh, this came out nice. Holy shit, really? That's neat. Am I looking at this right? 7, 5. Yeah, that's hilarious. All right, I'll take credit for that. Yeah, kids, I make that happen. No, I had no idea. I would have put money on the answer coming out gross, but it came out nice. Is that a problem? Is that something you have to throw out? No, it's not 8. It's not negative 3. So that's a valid answer. Does that sound familiar? Is anybody? All right, so you always got to check your answers here, make sure it doesn't freak anybody out in the original equation. Okay, so I got one question from chapter 2. Let me get there. Let me see. Where are you? There you are. Number, what was it? 56. All right. Oh, is that the same kind of problem? Oh, yeah, that's exactly the same. Okay. What's wrong with 56, Kyle? Is it, we did one just like that a minute ago. If I'm looking at the right one, that's the square root of x plus 9, that problem, right? Kyle, are you out there? There you are. Kyle? He gave up on me. He's like, this guy's never going to answer my question. Then he left. I'll be right. All right. Well, let me know if you come back, Kyle. Anybody have any other specific questions? I got one more thing I want to talk about. Let me see, where was it? Oh yeah, that's right. Okay, I want to do a little bit of a preview for that. By the way, all right, no other questions. Okay, I want to do a little bit of a preview of complex numbers. Can somebody tell me what a complex number is? 11t3. No. Anybody know what's a complex number? Sure. That's specifically, that's an imaginary number. Right? So this deals with, so it has the form a plus bi. It's got a real part. It's got an imaginary part. Now, this name, I'm tired of like bending down. Oh, I got to figure out how to do this. That name, imaginary, sucks. When we first created the idea of a negative number, they were called imaginary because somebody said, if you have 2 apples and somebody takes 5 apples, how do you have -3 apples? What does that mean? Is that an apple black hole? What is that? So everybody thought negative numbers were imaginary. We know today that negative numbers are not. In fact, when I was in college, very often I had to use negative numbers to describe my bank account. So I understood that negative numbers exist, right? And you can have negative temperature, and you can have negative profit, and you can have blah, 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 blah. But these poor things, what the shit is I? What is that? What is I? What do I be? What is I?
Square root of -1.
Yes. This exists. It's an actual thing. It's not imaginary. It's actual. It's a true thing, right? There's a really kick-ass video that I'll show you. Maybe not today. I got to find it. That goes over some really cool shit about imaginary numbers. But let me show you one little thing, and then we'll call it a day. If you multiply 1, what's 1 times -1? We're getting really deep now. What's 1 times -1?
-1.
Holy shit. So multiplying by a negative is a 180-degree turn. Does that make any sense to anybody? And
no.
This is how I teach people what's -1 times -1.
Is 1.
1. So it's a 180-degree turn followed by another 180-degree turn. So of course I come back to 1, don't I? So that's why you get a positive when you multiply 2 negatives. That is why. Now watch this. What if I only want to turn halfway? What if I just want to go here? I just want to go halfway. What is that? That is this. Doesn't that say half of -1? Isn't that what that says? So that's like a 90-degree turn. So there's a whole other axis that actually exists here, and this is the imaginary axis. And so, last thing I'll say, these really should be called lateral numbers because they're to the side, like your lats. If anybody works out, you work out your lats, the sides, side muscles. So lateral because they're to the side of the real number line. So they shouldn't be called imaginary, they should be called lateral numbers. That makes more sense. Okay, maybe. So I think next time I'm going to show you that video. We'll kind of, well, after I take specific questions from 1 and 2, chapter 1 and 2, we'll look at the video. We'll do some specific complex number problems, and we'll finish out chapter 2. That's the plan for tomorrow. I think that's enough for today. So let me know if you need to hang out, if you have any questions. Otherwise, you are free to go.
Thanks, Professor.
Sure. You're welcome.
Thanks,
and again,
Professor.
get into that chapter 1 and 2 if you haven't. So you got questions for tomorrow. That's makes things work so much better. Okay.
Goodbye, Professor.
See you. All right. Where can I find the homework? Oh,
real quick, Professor.
Yes.
On your syllabus, your office hours say to be announced. Do you know those yet, or is it just like a message you basis or?
Wait a minute. Let me show you. The to be determined part is the extra. Oh, good. Somebody likes my movie references. Let me show you real quick. I have definite office hours. They're always right before right before class time. See that? So 5 to 5:30. I'm here.
I gotcha.
And then this, I am going to add some office hours, but unfortunately, I'm on some committees, and those committees have not set their schedule yet, their meeting times. So I can't set my extra office hours times yet. So I'm waiting to see what the hell they do. So as soon as I know that, I'm going to have a few more extra office hours every week.
Thank you.
What was the other things? Somebody was worried about the homework. What was the other question? Shit.
They asked what exactly the homework was.
So watch this. All right. You know the homework for the whole semester. You know it. I've told you the homework for the whole semester already. It's right here. Homework. Timeline. Bam. You know all the homework for the whole, well, no, let me take that back. Until April. So this is part 1. So I'm going to come out with part 2 later. But you know all the homework. You can get ahead. Get ahead. Hell yeah. Get ahead now. Right? So yeah, definitely do chapter 1 and 2, but maybe even start looking at 3. 3 should be mostly a review also. But we're going to kind of slow down in 3. Right? All right, wait a minute. I can't see chat. All right. Are those due dates? No, those are not due dates. It sounds like you guys need to watch that syllabus video. So these are the dates that we'll be lecturing in these sections and chapters. The due dates show up in Canvas. So if you look at, even when you first log in, you'll see due dates here. See that? But also if you look at modules, the turn in here down at the bottom, you'll see due date here. And I'm going to start adding in like turn in chapter 3 homework here. So that'll be a module and there'll be due dates just like these have due dates. So you will find the due dates in Canvas. The dates on the homework sheet are dates we'll be lecturing in those chapters.
Oh, the other thing I wanted to ask is how come on the Canvas messaging it says John Waller?
Because my actual first name is John. And for some reason, the school will just not let me be known as Jeff. I've gone by Jeff my entire life, right? So my name is actually John Jeffrey Jingleheimer Waller. No, it's John Jeffrey. But for some reason, they just want to keep the John in there. I don't know. That's still me, though. That's still me. Does that make sense, everybody? I really hate it when it's like the 6th week and somebody's like, how does homework work? So I want to make sure everybody knows that now. All right. There's no other questions. I'm going to head out. You guys good? Okay, I'm
Thank
gone.
you.
I'll see you guys tomorrow. We'll do it again.